Hi everybody, in this video we are going to evaluate some more circular functions. So here we go. Once again, we have two approaches that we can use. We can either basically put our calculator in radian modes and have at it, or if we want to, we can convert to degrees and do our calculation. It kind of depends on what you're comfortable with. I know most people are not comfortable working in radians, so this might be for them. In one case, I will actually do them both ways. And this happens to be the case. So the first thing is we want to compute the sine of 3.42. So if I was going to do this in radian mode, well, first thing I would do is I would go over here to mode, make sure I am in radians, which is what I have right here. So let's just go. So we're good there. I can clear and I can do this particular problem. That is going to be sine of 3.42. Close my parenthesis, hit enter, and that will be my answer. Negative 0.27482. I'm going to assume that they want this to 4 decimal places. This is my 5th decimal place. This is less than 5. That means I can round this to negative 0.2748. Remember, we're doing this using the radian approach. Okay, now for the next one, I need to find the secant, but there's a problem here. I have no secant button, but I do know that secant of theta is equal to 1 over cosine of theta. So I can compute cosine of 5.6041 and take the reciprocal. And that's what I'm going to do here. So cosine 5.6041. There we go. That's my answer. I can use this button right here for reciprocal. And that will give me 1.28510. Once again, my 5th decimal place is less than 5, so I don't need to round up. This will be 1.2851. Now, if I wanted to use the degree approach, well, that means first that my calculator needs to be set to degree. And the primary advantage of using this, probably the only advantage, is that you'll never need to switch this around if you're always converting to degrees. You can just leave that the way it is. Okay, not convinced that's much of an advantage, but you never know. And if that's the case, then this is going to be equal to the sine of 3.42 times 180 divided by pi. Okay, so that will give us the sine of 3.42 times 180 divided by, and pi is right here, so second, the caret, close the parenthesis, and notice we get the exact same response, negative 0.27482, exactly what we have here. So you'll get the exact same number. And then for the last one, we can write this as 1 over cosine 5.6041 times 180 divided by pi. I should have made that a little bigger. And when we do that, it will be cosine 5.6041 times 180, 80 divided by pi. Notice we got the exact same number here. So when we take its reciprocal, we get the exact same number here. So they both give you the exact same response. Whichever approach you want to use, it depends upon what it is you are comfortable with. Okay, now for the next one, we are going to be given the sine value, and we need to figure out what s or theta is. Now for this particular problem, we want to take advantage of what we call the inverse functions. So if sine of s is equal to 3.210, then it follows that S is going to be equal to the arc sine or the inverse sine of 0.3210. Okay, and what we want to do here is we want to, and this right here is the inverse. Okay, now to do this, what I'm going to do is I'm going to take my calculator and I'm going to put it back in radians. So I'm going to highlight radians, hit enter, hit clear, and then I'm going to do second inverse sine 0.3210, close my parenthesis, and that is my answer. That is going to give me 0.32678. So once again, I'm going to go to 4 decimal places. Here's my fifth. That is higher than 5. So this will round to 0.3268. And that actually does turn out to be within this value, this quadrant. If you're not sure, what you can do is convert this to degrees. So I can multiply this by 180 divided by pi. And that is 18 degrees. 18 degrees is somewhat around here, so we are within the interval 0 to pi over 2. Now for the next one, we want to find the exact value of S in the interval 3 pi over 2, which is here, to 2 pi, if tangent of S is equal to the negative square root of 3 over 3. Now keep in mind that this is equal to also negative 1 divided by the square root of 3. We actually just have this because we need to rationalize the denominator. But to solve this problem, this is going to be helpful. And keep in mind that the tangent of S is always equal to y divided by x. So we want to, so it's going to be one of these 3 points. And we want to figure out which one of these 3 points is going to give you negative 1 divided by the square root of 3. We divide y over x. And keep in mind, this is x, this is y, this is x, this is y, this is x, and this is y. So the question is it 5 pi over 3? Well, if it is 5 pi over 3, then that would imply that the square root, then y over x is going to be equal to negative square root of 3 over 2 divided by 1/2, which will give us negative root 3. So it can't be that one. Okay, what about 7 pi over 4? 7 pi divided by 4. Well, if that's the case, y over x, remember this is y, that's x, is going to be nothing more than the negative square root of 2 over 2, which is negative 1. So that, root 2, sorry. So negative 1, that can't be it. So it is probably this one right here. And if you look at it, it's pretty clear that it is. So let me do that up here. That is going to be 11 pi divided by 6. Okay, well, y over x, y is negative 1/2. X is the square root of 3 divided by 2. And that gives us negative 1 divided by the square root of 3. This has to be the answer. Okay, so once again, the idea here is once we're looking for that particular ratio, we have a bunch of alternatives and evaluate each alternative based upon what you know about tangent, that's equal to y over x, to find the correct answer. And that's pretty much what we did here. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.